Hey everyone, so we're all using these new AI assistants, right? Asking them to write emails, debug code, maybe even just come up with a good recipe for dinner. But have you ever actually stopped and thought, how did this thing get so smart? Well, today we're going to pull back the curtain and look inside the AI's mind to see exactly how these incredible tools are made. I mean, that's really the big question, isn't it? We fire questions at it all day long. But it didn't just pop into existence knowing all this stuff. Its ability to give you a coherent, helpful answer is actually the end result of a really fascinating learning journey. And here's the thing. It's not magic. It might feel like it sometimes, but it's actually a very deliberate three-step education that's designed to take what is essentially a blank slate and turn it into the helpful conversational partner that you interact with. And this, right here, this is our roadmap for today. Now, I know it looks a little complicated, but it really just boils down to a three-part journey. Over on the left, everything starts with raw data in a process called pre-training. Then, in the middle, the model gets refined through supervised fine-tuning. And finally, on the right, it gets its final polish with reinforcement learning. We're going to walk through each one of these, starting right at the beginning. Okay, so step one. This is all about building a massive foundation of knowledge. Honestly, the best way to think about it is like giving the AI a library card to the biggest library in the universe, the entire internet. Its only job at this stage is to read absolutely everything it can get its digital hands on. And the scale of this reading, it's just mind-boggling. We're talking about the model processing over 1 trillion tokens, and you can think of tokens as basically pieces of words. This is so much more than reading a few books. It's about consuming a whole digital universe of text to learn all the patterns, the structures, and the trillions of relationships within human language. And this table really shows you the variety in its reading diet. It's not just one thing. The model is learning from huge web archives. It's reading all of Wikipedia, millions of books, and even tons of code from places like GitHub. So it's absorbing facts, conversations, different languages, and even logical structures, all at the same time. Now, here's the most important takeaway from this first step. The AI becomes what you could call an internet document simulator. It has this incredible, compressed knowledge of the world, and it gets really, really good at predicting the next word in a sentence. But, and this is a big but, it doesn't actually know how to be an assistant. It has no idea what a question is or how to give a helpful answer. It's basically a genius that has no idea how to talk to people. And that brings us right to step 2. So if pre-training was like sending the AI to university to learn all the facts, this step is like sending it to finishing school. This is where that raw genius learns some manners, how to have a dialogue, and how to actually apply all that knowledge in a real conversation. You can see here the whole strategy just flips. In step 1, it was all about massive amounts of data from the internet. Now we shift to a much, much smaller, carefully curated data set of super high-quality examples. That first step was incredibly expensive. This step, it's much cheaper and way more focused. It's no longer about quantity, now it is all about quality. And this diagram shows you exactly how it works. The process is called supervised fine-tuning, or SFT for short. Basically, human labelers create thousands of perfect examples, a specific question or prompt followed by the perfect ideal response. The pre-trained model then just studies these examples over and over and over again. And the goal here is really important. It's not to teach the AI new facts about the world. It got all of that in step 1. The real goal is to teach it the format of a helpful answer. By studying, maybe 50 or 100,000 of these perfect Q&A pairs, it starts to learn what it means to be an assistant, how to follow instructions, and how to structure a good response. So at the end of this stage, we have something that really looks and feels like a chatbot. It's pretty capable, it can follow your instructions, but there's still a critical piece missing. It doesn't have nuanced judgment. It doesn't really get what makes one good answer better than another good answer, and it might not know how to handle tricky or unsafe topics. And that leads us to the final and maybe the most important step in its education. This is where the AI develops its moral compass. This is where we align the model's behavior with actual human values, with our preferences, and with what we consider to be safe and helpful. We do this using a really cool technique called reinforcement learning from human feedback, or RLHF. This is really the secret sauce that makes the best models today feel so helpful and so aligned with what you actually want. It's designed specifically to teach the model what we as humans prefer in an answer, which goes way beyond just being factually correct. The key insight that makes all of this work is actually brilliantly simple. It's just that it is way easier for us to judge the quality of two different answers than it is to write one perfect answer from scratch. I mean, think about it. You can easily tell me which of two movie reviews is better, even if you couldn't have written either of them yourself. RLHF taps into that exact human skill.
So here's how it works in practice. First, we take a prompt and we have our AI generate a few different answers. Next, a human comes in and looks at those answers and just ranks them, from the best one to the worst one. Then all of that ranking data is used to train a totally separate AI called a reward model. Its only job is to learn human preferences. And then that reward model acts like a personal coach, fine-tuning our main AI to produce answers that it knows we're going to like.
And this diagram shows that whole feedback loop in action. You see the prompt goes into the AI, it generates a few outputs, a human labeler ranks them, that ranking data trains the reward model, and then that reward model provides the crucial feedback, that reward score that fine-tunes the main AI. It's this continuous cycle of improvement, guided completely by what humans think is best. And the results? They are just dramatic. Look at this graph. The lines down at the bottom show how helpful models are after just the first two steps. But that top blue line, that's the model after RLHF. The jump in quality is absolutely massive. Human raters judge its outputs to be way, way more helpful. This is the step that really, truly creates that next-level assistant that we're all getting used to.
So there you have it. We've just walked through the process of building a state-of-the-art large language model. But the story doesn't just end there. The chatbot we've described is really the foundation, but it's just one member of a huge and rapidly growing family of AI. And this slide gives you a little peek into that expanding AI universe. The kind of text-based model we just talked about is just one piece of this whole puzzle. You can see a whole zoo of different models here, each one specialized for a different purpose. So let's just quickly touch on a few of the big trends that are shaping where this is all going. First up, we've got vision language models, or VLMs. These are models that can see. They don't just process words, they can look at images, charts, and screenshots and understand what's in them. This is literally giving the AI a pair of eyes. Then there's this huge push towards small language models, or SLMs. These are designed to be super lightweight and efficient, enough so that they can run right on your phone or laptop without even needing to connect to the cloud. And that is a huge deal for things like speed, cost, and especially privacy. And finally, if we look a little bit further down the road, we have large action models, or LAMs. Now, these are AI agents that don't just talk, they do things. They can understand a goal, like plan a trip to Paris for me, break that down into steps, and then actually use tools and apps to book the flights and the hotels for you. So we've seen how an AI goes from being just a raw text predictor to a refined assistant, and how it's shaped at every single step by human knowledge and human feedback. The entire process is about aligning the machine with our values and our preferences, which, when you think about it, leaves us with a pretty fascinating final thought. We've basically taught an AI to be a mirror of us. What happens when the face in that mirror changes?